In question 10, it says that the diagram shows the curve y is equals to x square cos 2x. The curve has a maximum point at M where x is equals to p. We have to show that p satisfies the equation p is equals to half tan inverse of 1 upon p. Now, as it is a maximum point, we know that that means dy dx is equals to 0. So in the first step, we'll find dy by dx. And as two terms are multiplying, we'll use product rule. So we'll say u is equals to x square and u dash will be is equals to 2x. V is equals to cos of 2x. So v dash will be, so derivative of cos is minus sine and 2x derivative is 2. So minus 2 sine of 2x. So we'll write it as uv dash, or sorry, vu dash, that will become 2x cos of 2x plus, and this is a minus sign, so we can just write minus over here, and this will become minus x squared 2. So this is 2 over here and sine of 2x. And we'll put it equals to 0. Now, solving it, we'll bring 2x square sine 2x on the left hand side. So we'll have 2x square sine of 2x is equals to 2x cos of 2x. And now, as we have to satisfy the equation p, or we can say basically p represents x over here. So this 2 and 2 will cancel out. And we have x remaining over here as an x square over here. So x square and x will cancel out. And we can write it as, so we have to bring tan. So sine x upon cos 2x, that will become tan 2x. And we can bring this x on this side. So this will become 1 upon x. Now, as we have to find x, so this will become tan x is equals to 1 upon x. So if we take tan inverse over here, so this will become x is equals to tan inverse of 1 upon x. But there is 1 upon 2 over here as well. We have x is equals to p, so that's fine. So let's check if we have missed out on any value over here, because there's supposed to be a 1 upon 2 over here. So this is 2x, vu dash is 2x cos 2x, and uv dash is minus 2x square sine 2x. Okay, yeah, this is tan 2x over here. So this is sine 2x upon cos 2x will be a tan 2x. In place of x, now we can write p as well. So we can now write it as 2p is equals to tan inverse of 1 upon p. And then finally, p will be is equals to 1 upon 2 tan inverse of 1 upon p. Now in part 2, it says use the iterative formula to determine the value of p correct to 2 decimal place, give the result of each iteration to 4 decimal place. Now for this, we always need the initial value of p. So the initial value of p, we know that the value of p lies between 0 and 1 upon 4 pi. So we can start off by taking any value between 0 and 1 upon 4 pi. So 1 upon 4 pi is 3 3.142 upon 4. So this is more than 0.5. We can take any value. We can start off with 0.5 over here. So we can start off with the initial value 0.5, and we'll write it as, so the first value of p will become 1 upon 2 tan inverse of 1 upon 0.5, which is tan inverse of 2. Now substituting this in the calculator over here, we'll get, okay, so tan inverse of 2, and then we'll divide by 2. Okay, so shift tan inverse of 2, and we have to make sure that our calculator is in radian mode. Okay, so shift tan inverse of 2, that is 1.11, and then we'll divide our answer by 2, so we'll get 0.55. So this will become 0.55, and we have to give our answer to 4 decimal place, so that is 55357. So this will become 0.5536. Now we'll substitute this value to get the next value. So this will become 1 upon 2 tan inverse of 1 upon 0.5536. Now substituting this in the calculator, shift tan inverse of 1 upon 0.5536. Okay. And then dividing this answer by 2, we'll get 0.5325. So this will become 0.5325. Now substituting this again into the equation, we'll get the third value. So 1 upon 2 tan inverse of 1 upon 0.5325. So shift tan inverse of 1 upon 0.5325. And then we'll divide this answer by 2 again. We'll get 0.5407. And we'll have to do it a couple of more times. And our final answer will be somewhere around 0.4. We have to give a final answer of P to 2 decimal place. We can do it one more time. And if our answer is still coming to 0.54, we can give a final answer of P as 0.54. In the next part, we have to find, showing all necessary working, the exact area of the region bounded by the curve and the x-axis. So the total area, will have to integrate the equation, which is x square cos of 2x. And the limits are pi upon 4 and 0. Now to integrate this, we'll have to use integration by parts. And we know that the formula for integration by parts u dv is vu minus v du. So we'll apply the late formula over here where we have algebraic and trigonometric terms. So the algebraic term will be taken as u, which is equals to x square. So du will become 2x. dv will be taken as cos of 2x. The integral of cos 2x is sine 2x, and then we'll also divide this by 2. Now we'll just simply substitute this into the formula. We will get vu, which is x square sine 2x upon 2 minus, so this will become 2x. We can keep the 2 outside, and this will become x v du. So okay. So v du will become vu and then v du. So that is 2 over here, x and then sine 2x upon 2. So this 2 and 2 will cancel out, and we can now simply substitute, or we can simply integrate x sine 2x one more time using integration by parts. Again over here, u will be x, so du will become equals to 1. dv will be sine of 2x, and the integral of sine 2x is minus cos 2x and then upon 2. So now applying integration by parts over here, we'll get vu again. So vu will become minus x cos 2x upon 2 minus v du. So v is minus cos 2x, so we can make this a plus cos 2x upon 2 and then dx. Integrating cos 2x, we know that becomes sin x. So this is minus x cos of 2x upon 2. Integral of cos is sine, so this will become plus sine 2x. And then we divide by 2 again, so this will become a 4. We have a minus sign outside, and this remains as it is. Now simplifying this, we'll get x square sine 2x upon 2 plus x cos 2x upon 2 plus sine 2x upon 4. Now we have to simply substitute the upper and lower limits. The upper limit was pi upon 4. So substituting x is equals to pi upon 4 over here, we can do this separately. So sine 2 into pi by 4, that is sine of pi by 2, or sine 90, and we know that sine 90 is 1. And so sine 90 will become 1, and x square, so x is pi upon 4. So this will become pi square upon 16 into 1 upon 2 plus pi upon 4. Cos 2x will become, again, when we write x is equals to pi upon 4, that will become cos pi by 2, which is 0. So this whole term will become a 0. So we don't have to write it down. And then sine 2x is 1. So this will become plus 1 upon 4. Minus, Now substituting 0 over here, so this will be 0, this term will be 0, and this term will be 0 as well. So our final answer will be pi square upon 32 plus 1 upon 4. That should be the final answer. And if we take the LCM as 32, so this will become pi square plus this will multiply by 8, so 8 upon 32. There is there's just one correction over here. This minus and this plus should have become a minus over here, and these are the small mistakes that will be have to very careful about. So this should have become a minus 1 upon 4. So pi square, this will be pi square minus 1 upon 4, and we can write it also as pi square minus 8 upon 32. And this will be our final answer for the area of the region bounded by the curve and the x-axis.